This one, assignment for physiologic design. Boleh eh? Alright. So let me explain about the assignment. Okay. Right. So that I mentioned the previous class. So this is your assignment. Okay. So this assignment can be grouped by 3 students or can be individuals. Okay. Up to you. Alright. Up to you. For this one, I give because of the online. Okay. Because of the COVID, some of you prefer to do by yourself. So you can also do individuals. Okay, up to you. So this assignment can be grouping, okay, on consists of 3 students, okay, and also can be individuals. Up to you. Maybe 1 or maybe 2 or maybe 3 lah. Okay, so after this you can discuss lah. Okay, if you want to do by yourself, okay, you can submit as the individual or by grouping, right? Okay, so you can see on the assignment, okay, each group will be need to come up with design a physiologic control system for any real life application given okay, applications, okay, given model. All right, this is also the I mentioned the previous class. Okay, for example, if you have an idea or you have a model, okay, for example, like washing machine model, or you have the traffic light model, or you have the temperature control model. So you can also this model. You can also use this model to design your physiologic control. Okay, clear? If you don't have any ideas, okay, any ideas of the model, all right. So you can use this one. You can use either the given the given formula, the given model here lah. So on this assignment, you can see we have, I think we have 15 model, different model. Okay, we have 15 different model. Okay, you can choose the one which one you want to do your model as your model lah. Okay, if you no idea, okay, if you have an idea, all right, so also you can use your idea. For example, you want to okay, you want to design traffic light, okay, or washing machine, rice cooker. For example, you see that you got the rice cooker model. Also, you can use the rice cooker model. Okay, for this semester, it's not fixed on the given model. Okay, so this one you can also propose based on your model lah. Okay, for example, like your FYP. Okay, that is similar like my student before this. Their FYP using the water tank system. Okay, so they use the water tank system design to system model to design the physiologic control, right? So also can for this semester, right? Okay, so you will be needed to use the software tools such as Matlab, all right, Qt Fuzzy Light, Fuzzy Text, Labview, okay, for the assignment okay, but our class will focus on the Matlab. Okay, also you can use the Fuzzy Text. Before this, I also use the Fuzzy Text. I think the Fuzzy Text quite not too tough, okay, but it cannot run the simulation on the fuzzy lah. That's why I prefer to use the Matlab lah, because Matlab you can use the Simulink to run the complete system lah. Okay, on the fuzzy text, for example, you use the fuzzy text. Fuzzy text you can only design the fuzzy logics, okay, but you cannot run the overall system. Okay, that's why for this semester, okay, that I suggest to use the Matlab lah. Okay, use the Matlab to design your assignment. Okay, all right. So this, okay, format of report will be given, already given on the groups. Okay, each student should be submit the both format. Okay, but for this semester, you have to submit only the soft copy. Okay, only the soft copy. No need to submit the hard copy. Okay. Okay, for this semester, only the soft copy lah. Okay, including the design using the software tool lah, including the Matlab file. Okay, including the software. So you have to submit the reports. Okay, and also you have to submit in the Matlab. Okay, the Matlab design for the fuzzy logic. Right, that is for assignment. Okay, so for example, like if you see the model number 1 here, so model number 1 is the AUV, your control. First, you have to Google. Okay, you have to Google what is the AUV. AUV stand for what? Okay, AUV stand for what? Is the your control. Okay, AUV yaw control, and then you can Google what is the AUV, and then from the Google, okay, from the Mr. Google, you can get the introduction of what is the AUV, all right, what is the application of AUV, what is the definition of yaw control, and then this one already you can Google lah. Okay, for example, like this model AUV yaw control, you can Google and then get the some input data lah. For example, for the introduction, okay, for the literature review for this AUV. And then, for example, second model is the ROV, depth control. And then you can Google lah, what is the ROV? ROV stand for what? Okay, for example. And then from the Google, you can abstract for example, for the introduction from the Googles. Okay, what is the ROV? Okay, what is the definition of the depth control and so on. Okay, that is for introduction lah. So introduction you can Google lah. You can Google. Okay, you can get the data information from the Google. Okay, related to your model lah. That's why for this semester, I will be open. If you have any model, okay, for example, you Google, you found the given the real life application. Okay, for example, you see you got the rice cooker model, and then you can use. Okay, also you can use the rice cooker model to design the fuzzy logic control. Okay, so this semester not strict to follow the given model lah. So it's up to you. Okay, up to you lah. But if you no idea, you can choose either one lah. You can choose either one. We have 15 model, right? You can choose which one you want to use lah. Okay, the first step for design this assignment, all right. First, you have to design the closed loop. Okay, design the closed loop control system using the PID. Okay, I will show after this lah. Okay, this is last semester. Don't worry, after this we do some revision again to how to use the Matlab, okay, to design the fuzzy logic control. Okay, so the first step you have to design the closed loop, okay, the closed loop system using the PID controller. After you get the design and then you run, after you get the output, and then you can also use the auto tune, using the auto tune of the PID controller, auto tune. So auto tune, so this auto tune will be get the optimized value for P, I, and D. Right? Okay, so then you have to design the fuzzy logic controller. Okay, so this one you have to design using the Matlab, using the fuzzy logic toolbox. Okay, we call the fuzzy toolbox, or sometimes we use the fuzzy logic inference system lah. Okay, fish file. Okay, fish file, or sometimes I call as the fuzzy logic toolbox. Okay, so you have to design MISO system. That means 2 inputs and 1 outputs. Okay, 2 inputs, 1 output lah. Alright, that is the requirement for the fuzzy logic. That means you have to design the 2 inputs and 1 outputs lah. Okay, this one will be up to you. You want to design using the Mamdani or Sugino inference engine. Okay, the last class I already explained about the Sugino. Okay, so the difference Mamdani and Sugino is on the output. Okay, on the output. Okay, the output for Sugino is the constant or linear. That's it. Alright, for Sugino lah. But for Mamdani, similar like inputs. Okay, similar like input. That is the difference between the Mamdani and Sugino. Okay, or for this semester, also you can try the both. Okay, up to you. So from the previous student, they also do the both using the Mamdani and compare with using the Sugino. Okay, that I mentioned to you. So suppose Sugino better than Mamdani. Alright, so that's why my student, the previous student, will be compare using the Mamdani and using the Sugino. Alright, so and also that I mentioned to you is fuzzy better than PID. That's why after you get the fuzzy, you have to compare with PID. Suppose on theoretical, fuzzy is better than PID. Alright, so that's another theoretical that you have to prove lah. Okay, for example, Mamdani and Sugino. Suppose Sugino is better than Mamdani. Okay, because of actually it depends on the system lah. But mostly Sugino is better than Mamdani lah, because of the output you have just only the linear or only the constant. Alright, so the previous student they design using the both lah. They compare Mamdani and Sugino. Right, That is for inference engine lah. Okay, next. Okay, so you have to design 5x5 membership function. Okay, that means this is 5x5 is the inputs. Okay, that is the input. 5x5 is the inputs lah. There's two inputs. That means input number 1 will be 5 membership function, and input number 2 will be 5 membership function. Okay, and then you can use either you can use a triangular or you can use the trapezoidal. Okay, for simplicity normally I use the on the end side I will use the triangular, the trapezoidal, and the middle I use the triangular. All right, and then after you design this one, you have to try run the Matlab simulation using the Simulink. Okay, then you have to tune if the output is not so good for fuzzy. That's why you have to tune. Okay, you have to tune the output membership function, or you can tune on the membership function. Okay, or you can tune on the range of the membership function. Okay, that is another technique how to tune the fuzzy logic controller. Okay, on the dimension to you on the theoretical, suppose fuzzy better than PID lah. That's why you have to try. Okay, you have to try to prove this theoretical. That means the fuzzy is better than PID. Alright, that is for assignment. Okay, I mentioned to you this assignment depends if you want to do the individuals or you want to do the groupings, up to you. But the maximum is 3 students per group. Okay. Alright, class. Any question for assignment?
No, Doctor.
Okay, now so clear for assignment clear. So this assignment you can do by yourself. That means the individual, or you can do on the grouping lah. So the group will be 3 students. Alright. So next our class will be on the revision on the how to use the Matlab. Okay, to design the fuzzy logic control. Stop share this one. Alright, so first, this one I will revision for the previous class. Right, so this one will be revision on the how to design the fuzzy logics. Okay, fuzzy logic using the Matlab. Okay, so you have to open your Matlab. Okay, now I use the Matlab 2015A. Alright, so I think it will be similar lah. If you use the latest one, the command will be same lah. Okay, the command will be same. First on the command window, you can see this one, command window. Right, so type fuzzy. Okay, type fuzzy, and then enter will be the fuzzy logic toolbox lah, or FIS or FIS fuzzy inference system. Okay, will be appear will be appear fuzzy inference system lah. Alright, so I will share this one. I will share the fuzzy inference. Okay, so will be appear the fuzzy logic designer, or this one we call the fuzzy logic inference system lah, or fuzzy logic toolbox. Okay, so this one you can adjust lah. You want to use the Mamdani, okay, for inference engine, you want to use the Mamdani, or you want to use the Sugino. Okay, for example, you want to use the Sugino. Okay, click on the file. Okay, go for new FIS, go for the Sugino lah. If you want to use the Sugino. Okay, right. So this one you have to select the membership. You have to select the inference. Okay, you have to select the inference engine lah. Either for Matlab, either you can use the Mamdani or you can use the Sugino. Okay, alright. So this one, okay, this one for inference engine, you can use the Mamdani or Sugino. Alright. So that I mentioned on the class. Okay, for this assignment, okay, you have to choose two. Sorry. Okay, this one. You have to choose 2 input, 1 output lah. So you go for the edit, okay, add variable lah. So this one I want to add inputs. Okay, on our system will be 2 inputs and then 1 output. This is our our system okay, for assignment okay, this one you can adjust you can adjust the name of the input one, okay, up to you, depend on the system. Maybe you can I put as the error, okay, will be changed automatically, will be changed error here. And also okay, I click on the input tool, I put as the data error, okay, I put as the data error, okay, automatically will be change here, data error, okay. And then the output, okay, the output will be, I just maintain the output, maybe the output, for example, I put some output voltage, okay. So this is some example example for the output, okay, I put here, so automatically will be follow okay, this one on the fuzzy logic designer on the fish file, okay. So next step, okay, so this one no need to change, okay, this one no need to change for example the AND method, okay, this one related to Mamdani ada max min, you have to on the Mamdani, the theoretical, that we have the max min, so this one will be automatically will be changed, no need to change, okay. This one no need to change, please make sure no need to change but also you can change, but for simplicity no need to change this one also the defuzzification, okay, that I mentioned to you so for this question normally we use the centroid that means center of gravity. So you can click here, so we have a lot of technique here we have the bisector, we have the mom, we have the long, we have the som, but on the class we just cover on the centroid or center of gravity, okay. So this one maintain so this one no need to change, okay, no need to change, you just change this one for the name of the input or outputs, okay. And then next step you have to design your membership function so on the inputs, so you have to double click on the inputs, okay, double click on the inputs, will be appear membership function editor, okay, will be appear this one membership function editor. Right, so this one that I mentioned to you in our assignment, the minimum is 5 times 5 okay, 5 times 5, that means you have to add another membership add this one go file, add membership, okay. So you want to add another 2, okay, because this one we have 3 membership, so we have to add another 2 add another 2 will be appear another 2 here, all right, another 2. So next part you have to design back, okay. For example the membership one, okay, this one, okay, maybe I set as the small, for example small I put as a small negative SN, okay, will be changed SN, okay, maybe I change this one will be on the trapezoidal, okay. Next membership 2, okay, I put as the small and negative, I put as the negative okay, put as the negative, okay, I change the scale here, change the scale here, okay. For example this one you can straightforward using this one, okay, or you can use this one okay, straightforward using, if you know the range, automatically you can change on this parameter okay. For example this one I want to set as a 0.1 0.3 for example 0.3, and this one 0.5, okay. From this one also you can enter, so automatically will be 0.1 0.3 0.5, so automatically, all right. So next membership 3, okay, membership 3 also I change to 0.3 for example 0.3, you can adjust this one, okay, or you can adjust on the graphicals, okay, you can adjust on this parameter, okay. For example I adjust here profile, okay, this one okay, this one 0.7, all right. So this is for membership 3, I change to 0 okay, 0 name is a 0, okay, automatically get the 0 here So next membership 4, okay, membership 4 I change to, okay, maybe I put as the 0.6, 0.6. Okay, you can change here on the parameter or based on the graphical lah. Okay, I change 0.7 and 0.9 for example 0.9. Okay, enter. Alright, so this is our membership for. So I change the name. Maybe I put as the positive post put the post. Okay, or you can adjust this one. You can see this one not nice. Okay, I can adjust like this one. Okay, using this one, this part. Okay, or you can use the on this part on the parameters. Okay, next you can adjust on the membership file. So membership file you can adjust. Maybe we put as the big positive. Okay, for example, big post. Okay, big post. I want this one is the trapezoidals. Okay, so maybe I change this one. Okay, using the manual. Okay, all right. So this one. Okay, and then this one I change to big negative. Big negative. Okay, this one big negative, negative, 0, positive, big positive. Okay, this one we have 5 membership. So clear. This one we have 5 membership function. Membership function we call the as this one on the both side we call the trapezoidal. This one is the trapezoidal. This one also trapezoidal, and at the middle you use the triangular. Okay, this one is triangular, triangular, triangular. Okay, this one for input lah. For this one I adjust for input 1. Also you have to adjust on the input 2 and also the outputs. Okay, you can see this one. Click here will be changed. Okay, this one will be you have to design again the input 2 and also the output lah. Okay, the next part you have to also change the range here. Change the range for the input. For example, you know the input maybe from 0 to 10. Okay, also you can change from 0 to 10. Okay, on the group I already share some example from the previous student. So maybe you can follow. Okay, you can check try. Okay, for example, my student previous that I shared to the group. So maybe they put as the negative 10 to 10. Okay, this one the range from negative 10 to 10, so automatically be changed. Okay, this one you can see this one. So the range will be changed. All right, so will be negative 10 to 10. All right, automatically will be changed. Follow the range that you set. Okay, this one for example like input 1. Okay, and also you have to do on the input 2. Okay, input 2. Okay, and then also on the outputs. This one I will skip lah. Okay, all right. So this one I will just show for the input 1. I just show the how to design the input 1. Okay, similar you have to follow lah. Similar for the input 2 and also input the outputs. Okay, on the output. All right. Okay, next. After you design the membership function editor here, next part is you have to design the rules. Okay, click here, edit, go for the rules. Okay, go for the rules, will be appear the rules editor. Right, this one. Okay, will be appear the rules editor here. Okay, will be appear the rule editor. Depends that I mentioned to you. If you have 5 input 1, okay, membership function, that means you have 5, and input 2 you have 5, that means the rules you have 25 lah. Okay, 25. Okay, for simplicity to design this one, okay, to design this one that I mentioned to you before this, you have to use the table matrix lah, table matrix. Okay, right, you have to use table matrix, and from this table matrix you just substitute lah, follow based on your table matrix. Okay, for example you have the 5. Okay, for input 1, input 2 we have 5, and then what is the output? Okay, that means you have 25 rows. Okay, the connection for simplicity just use the n. Okay, use the n, the weight will be maintained 1 lah. No need to change. Okay, no need to change this one lah. All right. Okay, for example okay, for example, this is some example. Okay, so we have input 1, this is input 2. Okay, first maybe what 3 by 3 lah. Okay, so we have a 1, 2. Okay, this is a table that I mentioned to you. So this is a, we call it negative, 0, positive membership. Okay, membership for input 1, and also this one will be membership for input 2. Okay, and then inside this one will be our outputs. Okay, for example, our output we set as the 5. Okay, we have 5 outputs. Okay, that's mean similar like this lah. This one, that's why I mentioned to you, it's okay. You want to design more than 3. Okay, the input I just set as a 3, but output is 5. For example, this is a 0. This is small positive, and then this is a positive, and then this one is the small negative, and this is a negative. Okay, and then here you can set negative, negative. Okay, input 1 negative, input 2 negative. So maybe you can set as the negative. And then, for example, next rule. Okay, input 1 will be 0, and then will be negative. Maybe I set as the small negative. And then this one is the positive. Input 1 positive, and input 2 is the negative. Maybe I can set as the small negative. All right. So this one. Okay, next for this one negative 0. Maybe I can set as the small negative. Okay, this one maybe I can set as the 0, for example. Okay, this one I can set as the positive, and then 0. Maybe I can set as the 0. Up to you. Okay, and then for this one maybe I can set small okay, negative, positive. Maybe I set as 0. This one I can set as the small positive. This one is a positive. Okay. So from this table you can design, okay, on your Matlab lah. Okay, for example, I just show for this rule number 1. Rule number 1. Okay, if input 1 is n, okay, the connection is n. Okay, input 2 is n, then output will be n. Okay, this is rule number 1 lah. Okay, rule number 1. So for example, this is rule number 1, number 2, number 3, 4, 5, 6, 7, 8, and 9. Okay, for example, it's okay 9. Okay, 9 rule. If input 1 is is the positive, and input 2 is positive, then output will be is a positive. Okay, this one. So based on this table, okay, based on this table you can create lah. You can create the rule on the Matlab. Okay, the rule on the Matlab lah on this one. Okay, this one. Alright, from the table that I mentioned to you, Alright, so from the table, so we have 9 rules. So from the 9 rules, we can create this one, this table. Okay. For example, this is some example I just create. Okay, you can create here. Okay, and okay, as example here. Okay, so you can add the rules. Okay, for example, you want to change. Okay, for example, the rule number 1. Okay, go rule number 1. You want to change the, for example, you want to change the connection. Okay, the connection here, I change to, I click here, or, okay, so click here, change rule, okay, click on the change rule. So automatically you can see this one, automatically the rule number 1 will be changed to all, okay, will be changed to all here, right? That's it. For example, also you want to change now rule number 2, so click here and then change the rule. Okay, also you want to delete. For example, rule number 3, so you can click here lah for delete. Okay, automatically we delete lah. Alright, so that's it. Okay, that's it for fuzzy logic toolbox. Until this one, the next maybe you can check the surface. Okay, this is you can check the surface 3D dimension on the rules. Okay, and also this one is you can check the output lah. You can study on the do some analysis on the output for your fuzzy. Okay, if you click this role, all right, so will be appear role viewer lah. Okay, will be appear role viewer, and then if you click here, surface will be appear the surface lah. Okay, surface viewer. Okay, I will show. Okay, this one this is surface viewer surface viewer on the 3D lah. So you can see this one so this is input 1, this is input 2, and this one is the output voltage. Okay, this one will be shown on the 3D dimension lah. Okay, on the 3D dimension on the your input and output. Okay, normally this one is just show the surface viewer lah. Normally we don't not okay, we use the rules viewer to study the output lah. Okay, I'll show you this. Okay, normally we study this one okay, on the rule viewer so you can this one so normally we study this one study the output. You can see so from this one also will be given the output. Okay, for example, I set as the 0 here, and then this one I set as a 0. Okay, suppose output voltage is the 0. Now you can see this one is not 0. Okay, now will be 0.5. That means still we have the value. Okay, for the output, but on your system you want if error 0, output 0. Okay, input 1 0, output for data error is 0. Then you want to voltage your 0. So that's why you have to change the range here. Okay, change from -1 to 1. So automatically your output will be 0. Okay, there is some analysis that you can do. Okay, using this rule viewer. Okay, clear So for example, this is I want to show some example that related to our class. Okay, so for example, rule number 1, you can see this one so that on we will cover on the midterm. Okay, on the midterm test. Okay, you can see normally like this okay. All right, so if you see the connection is OR, I use the OR before this. I use the OR. So from this point and this point, I use the connection OR. That means they have select the maximum. So that's why the output will be here. Okay, you can see the second. Second, I use OR. Okay, I use OR. Okay, I use OR. Okay, that's why. Okay, I use the OR connection. All right, so I get this one. Get this output. Okay, but no connection on the because on the rule number 3 we have no output here. So you can see this one that's why last part you have to add output for B1, B2, B3, and then this is the last B total that mentioned on the class so clear this one. So that's why from this is some example. Okay, normally on the test or final, so just focus on the 2 rules or 3 rules. Okay, but on the design Matlab, for example, if you design 5 membership function for input and input 1 and input 2 and also output, that's why we have 25. Okay, that means here you have 25 input. That's why at the end you have to plus B total, B1 plus B2 plus B3 until 25. Okay, until 25 graphical output right. So here so that's why this is our outputs. Okay, and then we use the center of gravity, this one, and the Matlab use the center of gravity that we set on the early stage. Okay, on the fish file you can see, so they find use the center of gravity centroid to find the red line is the output so the output go for our system will be 0.358. Okay, this value go to our system our plant. Okay, for example, your plant is the AUV yaw control, so this value 0.358 go to our system. Okay, all right, so that's all for design fuzzy logics. Okay, next go for okay all right, so next last part. Okay, go for the Matlab. Okay, the Matlab, and then go for the new. Okay, and then click on the simulating model. Okay, now we have to design the simulating. Okay, design the simulating. Click on the simulating model, will be appear the file for the simulating Okay, we have to wait. Okay, still waiting. All right. Okay, will be appear. Okay, I stop sharing. Okay. Hmm. Okay, will be appear the file for Simulink. File for Simulink. This one. So from this one, you can click. This is our library. Okay, our library. You can click on the library. Okay, so first that I mentioned to you, you have to design the PID controller, closed loop PID controller. Okay, so normal we use the marks. Okay, we use the scopes, we use the sum. Okay, we use the function. Okay, on the continuous. Okay, this is our function. Okay, first step we use the PID that I mentioned to you, right? So this is our source. Okay, our output, input. Sorry, input. We use the step. Okay, we use the step input. Okay, so that's it for Simulink lah. Okay. Okay, so go here and go here. Okay. Alright, so this one go for this one. Okay, this one go to output feedback. So feedback will be negative. Error will be negative. This one will change to negative. Okay, so that's it for our system lah. Okay, so the part one already finished this one. So okay, based on the design, for example, you can see on the, for example, here you want to change the model. So double click on the drum function here, so you can change lah. Okay, for example, if you refer to the take one example. Okay, maybe I just change one example lah. Okay, so this one maybe I put as the 8.6. Okay. Okay, this one. 10 point something. Okay. Okay. Right. So you can see apply. So will be appear your model. So this is model lah. Okay. This model. For example, just give a model here. Maybe I just try the model function here. Okay. That's all for first step. Okay. The first step design the PID lah, the closed loop using the PID. Okay. The first you have to run lah. Okay, you have to run the submission. Maybe I change to 50. 50. The times for submission maybe in the run submission. Okay, and then you can check the scope lah. Double click on the scope. Okay, so you can check the response or not so good. Okay, okay, not so good. Okay, maybe we can increase. Okay, not so good. So maybe we can increase to 500. Okay, the time for submission. Alright. Okay. So, alright, I will show the output. Okay, I will show the output here. Okay, the scope. Okay, so this is our system lah. Okay, you can see this one. So at the end, so our system will be stable lah. Will be follow the set point. Okay, our set point will be 1. So at the end, our system will be follow the set point will be 1 lah. Alright, so this one still we not tune. We not tune the PID. Okay. Next. Okay, next go for one. Okay, next go for this one. You can click on the PID controller here. Double click on the PID controller. So when you click the PID controller, will be appear this one. Okay, I will share it. We share the PID controller. Okay, when double click, okay, when double click the PID controller will be appear this one function block parameter PID controller. So the initial value P is 1, I is 1, and D is a 0. Filter coefficient is 100, and then you can click here. You can click on the tune. We call the auto tune this one. So will be appear lah. Okay, first will be do the linearization plan and then find the optimized parameter. optimized parameter for P, I, and D lah. Okay, so and then will be appear the PID tuner. Okay, so will be appear the PID tuner. Okay, I'm not sure you can see the PID tuner. I will show. Maybe you can share. I share the PID tuner. Okay, so will be appear this one that will be appear PID tuner. We call the PID tuner. So this one you can show the parameter lah. You can click on the show parameter. So will be appear the parameter lah. That I mentioned to you will be appear the value of P and I and D lah. Alright. So initial that I mentioned to you, initial is the 1 for P is 1, I is 1, 0. Okay, and then after tune, and then the value of P is 0. Okay, I is a 5.118 and D is 0, and then the coefficient is the same. And then you can check the performance. The performance, okay, for example, will be improved. Okay, before tune, the rest time will be 140 seconds, and then after tune, you can get this one will be improved lah, from 140 to 33.4 seconds. And also the certain time will be improved, okay, from 246 seconds to 64.8 seconds. Okay, and also overshoot will be same lah. And then you can see this one will be okay. This one our system will be okay lah. So once you accept this one, this performance, okay, all right, you can update the block here. Click on the update block, so automatically will be changed lah the value parameter based on your based on optimized parameter lah. Okay, and then from this one we can run again the Simulink lah. Okay, run again Simulink, and then you can double click, automatically will be changed, follow the previous value lah for P and I and D lah. Alright, so and then you can run again, then check the output lah. Okay, so will be improved. Okay, improve on the rise time, on the center time, and also the overshoot. Okay. Okay, that's all for design the PID. Okay, next, okay, using the same Simulink. Okay, I will. Okay, this is Simulink. Maybe you can copy this one, copy and paste. Alright, but this one we focus on the fuzzy. Click here. Okay, the rest will be shared. So this one will be shared lah. We use the same input. Okay, this one will be use fuzzy. Okay, this one feedback same. Okay, this one scope we can share. Here. Okay, this one will be changed to 3, and then this one delete. Scope 3, delete. We share with this one lah. Okay, so now scope will be appear 3 signal lah. Will be appear inputs, okay, on the PID and also the fuzzy. Okay, so this part you have to on the library find the toolbox for fuzzy. Okay, this one will be appear. We have 3. Okay, if you click the fuzzy logic toolbox, so will be appear 3 types lah. We have the membership function, fuzzy logic controller with rule viewer lah. So normally I use the fuzzy rule. Okay, fuzzy logic controller. This one will be appear this one. Okay, all right. So as we know, I mentioned to you, so our inputs, okay, for fuzzy is 2. We have 2. That means we have used 2 lah. Okay, this one we have 2. Okay, we have 2. Okay, one from the error. Okay. Okay, so another one will be data error lah. Okay, derivative lah. So maybe from this one. One from the error, one is the derivative of error. Okay, this one, another one go here. Right, so one go for the error, another one go for the derivative of error, and then we have 2 input and go for the, and then this is what output lah. Okay, our output is here. Okay, so the output will be go on our system. Then you can, before you run, okay, you cannot run here, cannot run again. This one cannot run yet. Alright, so double click on the fuzzy logic controller. This one fuzzy, double click. Okay, double click, and then you have to fish file. Okay, you have to so before this you have to design the fish file. Okay, the fuzzy inference system or the fuzzy toolbox. You have to save the file name lah. Okay, for example, I save as the fuzzy. Okay, I save as the fuzzy. Okay, then apply. Okay, so okay, that's it for Simulink. Alright, after you click here, double click will be enter the file name for the fuzzy inference system. Okay, after you that you have to mention to you before you run this simulation, this Simulink, you have to go back to the fuzzy. Okay, go back to the Matlab. Back to the Matlab. Okay, Matlab. Okay, go back to this one. Okay, click again fuzzy. Click again on fuzzy on the command window. Alright, so we will appear this one. Okay, I will share. Okay, will be appear this one after you click the fuzzy. Alright, will be appear this one, and then go for import file. Okay, from the previous you have save. Which one you save? You save from the file. Okay, maybe I save in the desktop. Okay, desktop is the fish file. Okay, this one. Okay, so will be appear the previous. Okay, stop sharing. Okay. Okay, will be appear this one so the file, the fuzzy toolbox that I designed before this. Okay, the fuzzy logic designer, and then the file name I save as the fuzzy. Okay, this one you can see the file name make sure same with the on the Simulink. Okay, for example, the capital F, make sure you substitute the same, follow the file name lah. If you have the capital, okay, the numbers, so make sure you just follow. Okay, and then the last part you have to go file, okay, export to workspace. Okay, this is last part. Okay, last part. Okay, go file, go for export, click on the to workspace. Okay, click here. Okay, will be appear the save current fish to workspace, and then okay, click OK. Click OK. So you can see on the Matlab command window on the workspace, you can see the this one you can see our file here. Okay, on the workspace you can see this one the workspace. Okay, we can see our fuzzy. Okay, will be appear here. Then you can run your Simulink. Okay, then you can run your Simulink lah. Okay, that's it for how to design the fuzzy logics. Okay, using the Matlab and also using the Simulink. Okay, using Simulink. First, I teach about how to design the fuzzy logics. Okay, using the toolbox, fuzzy toolbox, using the fish. Okay, fuzzy inference system. Then to design the fuzzy logic using the Simulink. Okay, and this is the last part lah. After that, you can run the Simulink. Okay, share again. Okay, go for your Simulink. Alright. Okay, this one. Then you can run. You can run. Okay, so this one maybe okay, this one we have some error lah. So this one because of this I just use the previous example normally we don't have the error lah. Okay, so you can run. So automatically we will run lah. Okay, we will run, and then you can check the you can check the scope. Okay, the outputs. And then you can compare lah. Okay, normally the first before you after you design the fuzzy, normally the result for initial result is not so good lah. Fuzzy is not so good. Okay, that's why you have to tune. Okay, that's why you have to tune. Okay, that's why you have to remember this one. You have to tune until you get the best result lah. Okay, that's why fuzzy take time lah. okay, for the beginner one. So we take time to tune on how to tune. So okay, I will show you. This is some technique you can tune. Okay, all right. So first, so not here. Okay. Okay, so first you can okay, this one how to tune how to tune our fuzzy logic. So first you can tune on the input, okay, on the range here. Okay, for example, input one, you want to change the range. Okay, you can change the first, you can change the range, and then second, you can change the for example, the membership parameter. Okay, you can change here. You want to change, okay, for example, right? Okay, and then also you can change on the data error, or also you can change uh, on the this one on the outputs. Okay, all right. So this is a technique that you can tune, and also another one is the rules. Okay, the rules lah. So that's why for simplicity that I mentioned to you, for the rules normally we use the tables, so no need to change lah. Okay, no need to change. That means no need to tune on the rules, but you have to tune on this part lah, on the membership function editor. On this part, you have to try and error on the range. Okay, for example, this one, the depth I set as the from 0 to 50. Maybe I change from 0 to 100. It's up to you. Okay, that's why it will be the time lah. For beginner, will be the time to get the best. Okay, to get the best response for fuzzy lah. Okay. Right, so that's all for how to design the fuzzy logics, okay, using the Matlab. And so make sure it's normal after you design the fuzzy logic every time, okay, make sure so every time we adjust the parameter, okay, you have to make sure export to workspace every time. Okay, every time before you do run the simulating, make sure you export to workspace every time. That's why we'll be update your new ones. Okay, for example, you change first, you change the parameter. Okay, so and then you want to see the performance. Okay, before you run the simulation, okay, run the simulating, go export to workspace. Okay, export workspace and then run again, run the simulating. Okay, and then see the result. It's not so good. Okay, go back to the fuzzy tools. Okay, and then change, for example, change the parameter, change the membership. Okay, change the parameter before run the simulating. Make sure export to workspace, export to workspace. Every time you do the changing on your fuzzy logic, make sure you export to workspace. Okay, that's why we will be update. Okay, your on the simulating will be update based on the previous. Okay, on the latest one. Okay, latest one lah. That's why every time you adjust the or you tune your fuzzy logic, make sure you export to workspace lah, and then you run the simulating. So will be follow the latest one. Okay, follow the latest one lah. Okay, class. Okay, that's all for revision of our today class. Is the first is the revision on the test, second revision on the assignment, third is the revision on the Matlab. Okay, right. So next week we have midterm breaks, and then after midterm break we go for the new topics. Okay, we go for new topic, that is the artificial neural network. Okay. So the next topic we will go for the artificial neural networks. So before that, before I end of my class, so if you have any question, ada soalan? Boleh?
No, Doctor. Everything is
okay.
clear.
Sorry, tak dengar.
Everything is clear, Doctor.
Okay, clear. Alright, right. So for example, like assignment, okay, if you want to do the individual also okay, or you want to do the by grouping also okay lah. Okay, for because of the quite tough lah, because the quite tough to do some discussion lah. But if you can set together to do the assignment, it's okay lah. So I will leave it to you. So you want to do an individual or you want to do the by grouping, is okay for me. Okay, all right. Okay, if no question, I will check again. Okay, alright, boleh Okay, everything is okay. Right, so if no question, I will stop here. Alright, so next week will be breaks. Okay, so will be okay. Please make sure so our test will be on 9 December. Okay, boleh on 9 December because of I forgot because of the 16 December I have the conference. Okay, I have the conference. So maybe our midterm test one for biology is the 9 December at 8:30 to 10:30. I think it's just straightforward test lah, don't worry, straightforward. So normally you can score lah. Okay, you can score this one, please, but make sure do not do the simple killer mistake lah that I mentioned to you before this. Alright, so if no question, okay, I will stop here. Okay, so thank you very much. Okay, Assalamualaikum warahmatullahi wabarakatuh. Okay, terima kasih semua.
Thank you, Kak.